In this lesson, we're going to find the areas of three different types of figures. Obviously, you can see that that's going to be triangles, trapezoids, and rhombi. Now, a little review of how do we find the area of a parallelogram. That one you're going to need to have implanted into your head. It's going to help us out today. We're going to do the same thing as that we did before of base times height. Now, what I want us to think about is back to our properties of parallelograms. If I put a diagonal into a parallelogram, what does it do to it? Remembering back, it cuts that parallelogram into two congruent triangles, which is going to help us find the area of a triangle. If we did base times height to find the area of that whole orange parallelogram, well then to find the area of just one of those congruent triangles, cut the area in half, and I would have the area of one of the triangles. So that brings me here to find the area of a triangle. All we're going to do is take the area of a rectangle, or excuse me, of a parallelogram, base times height, and then cut it in half. So area of a triangle, 1/2 base times height. Now, the part you have to figure out is where's the base and where's the height. And it really doesn't matter. A lot of people always want to put the base on the bottom of the triangle, which you can do. Now the height, remember the height is always perpendicular to the base. So in this case, my height is going to have to, and it always has to go through the opposite, or the vertex that's opposite the base, which in this case is up here. Now I have to make a segment that's perpendicular to my base through that green point. Well, to do that, we're going to extend the base. Now we're not extending the length, we're just putting that out there so that we can find or calculate the height, which would be right here. As long as that's perpendicular, here's my height. If I know the length of B and the length of H, I can find the area of my triangle. Now I'm doing this again just to show you that it does not matter. Still have the same formula. Now maybe you want the base of your triangle to be here. Well, then the height's going to be in a different place as well. Find that vertex that's opposite of it, which is here, and now we have to find a segment that's perpendicular to our base through our green vertex. So I'm going to extend that side again, and then I find out that my height is going to be in that area, and that would be my height. I know the length of B and I know the length of H, I'd be able to find the area. And then I'm also going to do it here where, well, maybe you want this side to be your base. Well, then your height has to go through this vertex, and now the height is going to be on the inside of the triangle. Right there would be our height, and we'd be able to find the area of the triangle using the same formula that we did in the last one. Area of a triangle equals 1/2 base times height. Now you move on to the trapezoid. Well, in the trapezoid you have kind of three important pieces, the two bases and the height. They're going to be used to help us find the area of the triangle. What I'm going to do to start is I'm going to show you where the formula for a trapezoid comes from. It comes from taking that trapezoid and cutting it in half. And what we do then is we have created two different triangles. We have a triangle here, call it the bottom triangle, and we have a triangle here, I'm going to call it the top triangle. So if I could find the area of the two triangles, add them together, I'd have the area of my trapezoid. So the area of my trapezoid, well, I'm going to work with the bottom triangle first. It's going to be 1/2, well, times the base. The bottom triangle has a base of, call it B1, as you can see. And the height, well, my height would be right here in that triangle on the bottom. Well, that height right there is no different than the height of the trapezoid, which is H. So I can do 1/2 times B1 times H. There's the area of the bottom triangle. Now I have to find the area of the top triangle. So 1/2 times the base of this one, I'm going to use the B2 as the base. And if B2 is the base, then really my height is actually going to be here with my base extended. Well, that's also H long, so it's right there. Here's one formula for the area of a trapezoid. It's not a formula that I would use, but it is a formula. Now what I'm going to look at in this is there's definitely pieces that could be factored out of each term here. I look at both of them have 1/2. Both of them have H. So if I factor those two out, the only things that are left in each one of those terms would be the B1 and the B2. There you go, you have the area of a trapezoid. Now, that's not the one that I like to use either, for whatever reason. I like to have it, I'd call it kind of alphabetical order. So I'm going to go area equals 1/2, and I'm going to put my bases next. So B1 plus B2, and then times my height. So it's kind of in that same order as a triangle of 1/2 base times height, same order as the area of a parallelogram of base times height, and this is the one that I would use. Not saying that you have to use this one, but that's the one that I like. So there's your formula for finding the area of a trapezoid. Now my next one is going to be the rhombus. And the first thing I'm going to do is I'm going to think back to, well, a rhombus is a parallelogram. So if I want to find the area of a rhombus, I'm just going to have to do area equals base times height. And I'm done. I have one way to find the area of a rhombus. Now there's another one that we can come up with, and that one deals with the diagonals. So in this one, I'm going to call this red diagonal. Now the whole thing, I'm going to call diagonal 1. And then my blue one, I'm going to call that diagonal 2. And I want to find the area of this rhombus using the two diagonals. I'm going to go back to properties of a rhombus. I know the diagonals are perpendicular, and I also know that the diagonals of a parallelogram are congruent. Or excuse me, they're not congruent, take that back. They bisect each other. That's in a parallelogram. So I know that much information. Now, I'm going to look at this in terms of, well, I see a bunch of triangles in here. There's a triangle right here, which is going to be congruent to this triangle. And the reason it's congruent is because of side angle side. I noticed that both triangles have the single tick in them. Both triangles are going to have the right angle, the green right angle symbol in there, and both triangles have the double ticks. So side angle side tells me they're congruent. But I could keep going on, and I know that the yellow triangle is congruent to this triangle as well, and it's congruent to this triangle. Which basically tells me if I could find the area of this yellow triangle, multiply it by 4, I'd have the area of the whole rhombus. Now I'll go back to your diagonals being bisected. Well, this length right here is going to be 1/2 the length of diagonal, oops, not 1, diagonal 2. And this length in the triangle is going to be 1/2 the length of diagonal 1. So now I look at it, I have a triangle. I know how to find the area of a triangle, 1/2 base times height. I should be able to find the area of that yellow triangle. So I'm going to do, for my rhombus, I'm going to do area equals, and I'm going to find the area of one of those triangles, so 1/2 times the base, and being my blue segment and my red segment are perpendicular, it really doesn't matter which one I pick for the base. So I'm going to pick the red one as the base. So here's base 1, or excuse me, base and the height. So here's my base, 1/2 diagonal 1, times the height of my triangle, which is going to be 1/2 of diagonal 2. And there you go. There's the area of my triangle. Now remember, there's 4 triangles in that rhombus, so if I take this and multiply it by 4, I'm going to have the area of my rhombus. Now it's just a little bit of simplifying. What I'm going to do first is I'm going to look at the color here. I'm going to look at this 4, and I have 1/2 here. That can become a 1, and then which make this 4 become a 2. But then I have the 1/2 here. That 2 is going to become a 1, and this 2 will become a 1. Now the only thing that's left is that 1/2 from the blue. So I have 1/2 times diagonal 1 times diagonal 2 is all that's left. So here's another formula to find the area of a rhombus. If all you know is the length of the two diagonals, I would use this formula. If you know the length of the base and you know the length of the height, then I'd go back to my parallelogram formula to find the area of a rhombus. And then that will conclude my lesson on areas of triangles, trapezoids, and rhombi.